Katie Roberts from NearForm. I'm super excited to hear about this because I'm one of those people who basically uses AI to create new things and then abandon them. So what I'm interested to hear is what Katie from NearForm has to say about Brownfield Codebases. Please, big round of applause for Katie.
Hello. Yes, hello. I'm Katie Roberts. You might recognize me from such tracks as The Latent Space, where I've been emceeing for the last day and a half. And I'm here to talk to you about how you can stop maintaining and start evolving, applying AI native engineering in Brownfield Codebases. So a little bit about who I am. I am a technical director at NearForm, where I've been for the last 6 years. Prior to that, I was at the BBC, where I worked across a variety of products on the digital platform. A little bit about who NearForm are, because we are one of the sponsors of the event. So we are a consultant services organization. We support our clients in solving difficult software problems. We are hiring, in case you're interested, and we've got a booth downstairs. So please do come and chat to the people down there if you're interested to learn more about us. So AI native engineering works, and I know this because I've seen the numbers. And on greenfield Codebases, the benefits of using AI engineering are completely undeniable. It's the perfect place, a match made in heaven. We can do things right from the start, being the design, the product, and the architectural decisions. They're all kept together in one spec, and we can use this as a basis for our build. We define what systems should do, we get our agents to handle the implementation, and this means that product managers can have more input in the development process, we get to prototypes earlier, we get UX feedback quicker, development teams can move faster, we start building and testing and observability much, much earlier in the process. And a lot of the talks I've seen at this conference, and to be fair, other conferences as well, tend to focus on this. And that's also where a lot of the metrics that get reported in the press seem to come from these type of builds. And yeah, we've seen the same at NearForm, and we're saying the same things as well. So yeah, 80% faster kickoff. We are able to go through our product and design process in a much more slick, rapid, and realistic way. We've reduced our sprint zero times because we're getting our artifacts from our discovery process, which then is bootstrapping our sprint zero. So the timelines for that have shrunk. We're 50% faster to MVP. We've seen 4 times development philosophy. And all of this that means that there is much more time to focus in on some of the things that can get lost when you're trying to build out to that MVP very quickly. So the non-functional considerations are brought in from day one. Things like accessibility, security, and performance. And as Hannah Foxton said yesterday, the velocity problem is not really the development problem anymore. We can all move a lot faster. Except not all of us can, because in the brownfield, the reality is very different. Mature code bases account for an estimated 60 to 70% of enterprise software. And they are very successful. They're hugely successful. That's why they've been around for 5, 10, 15 years. But with that comes accumulated technical debt, tribal knowledge. Have you ever worked on a code base where something was developed by somebody who's long left the organization, and really the only documentation was in their head and they meant to write it down before they left? Dependency rot. You may be falling behind with a couple of dependencies, and suddenly upgrading to the latest version of Node is going to take 2 months rather than 2 days. Fear-driven development, places in the code base where people just don't want to go. They don't want to touch it because it's so fragile. Test poverty. This may be an unpopular thing to say, but tests didn't always get written. When you're under a lot of pressure, tests are some of those things that can get left behind, or they become so brittle that they're meaningless. So integration tests and user tests with Cypress, we've seen them just die off, and then people ignore them. And then there's pointless having them there. Interdependent systems that are tightly coupled, invisible contracts that you just can't see. And that results in high maintenance costs. Developers spend more time deciphering the code and fixing bugs and resolving issues than implementing new features and improvements. Small updates become really difficult, change becomes hard, feature development starts to crawl. Anyone who's stuck in this space as well becomes very demotivated. And it's nobody's fault, because every decision on this code base was made with the best possible intentions. Nobody wants the code to get like this. And it's sometimes referred to as the ball of mud pattern. I don't think of brownfield code bases as a ball of mud, though. I think of them much more like a city. A city is very successful, and it's something that's evolved over time. And brownfield systems tend to work like this. They work incredibly well. They have huge numbers of customers working on them. And that is why that they've been around for 5, 10, 15 years, whilst maintaining complex user demands, and all the time working through problems like performance, security, and scaling that come with that. And like the city, they've evolved as a response to the needs. And there are areas in that functioning city. So this is actually London. I took this last weekend from one of the top of the skyscrapers. I'm very pleased with this picture. It's lovely. But you can see on this, you've got paths through the city which are very, very clear. These are the well-trodden paths, the ones that we all know where it's going. And then there are less well-maintained spaces, dead ends, and the places that you really wouldn't want to get caught in alone late at night. So this is like your code base, and you want to evolve it into something that is easier to build on, that's more understood, and you get that high-level view so you can start working through. So I want to talk to you about how to evolve your architectures on Brownfield Codebases. And I've got 3 different methodologies that you can have that you can start thinking about if you're wanting to move your Brownfield Codebase onto its next steps. First off is the pseudo greenfield development. And I think this one, I've seen this happen quite a lot. It's really great when your legacy code base is really coupled or fragile, and developing inside it has become very slow. Velocity is starting to crawl. And effectively what you do is you branch out and say, right, this new feature, I'm going to develop it, and I'm going to treat it like a greenfield code base. Now, when you do this, you tend to see a really fast iteration at the beginning. You can move very, very quickly. But then you get to the point where you're starting to merge the branch back in, and things start to slow down. It is really, really fantastic. And people who are doing this, the developers who are working on it start to become kind of tourists. They never learn about the underlying problems of the code base. You can end up with duplication of shared concerns, so things like authentication, logging, error handling. You may end up on your pseudo greenfield branch duplicating things that the legacy system has already solved, which means that you end up with twice the amount of complexity because you've got diverging approaches. The longer your greenfield branch runs in isolation, the more the branch diverges, the more expensive it is to do reintegration. Without discipline as well, this temporary isolation strategy can become a permanent fork, which is another problem. And you don't really get to test how the code is integrating well together until you get to that last point, point 4 here, merging it back into the code base. And that means that you can end up with a huge amount of bugs and test and refactoring as a result of that reintegration. But it is one development pattern, and it can lead to the next one, which is the Strangler Fig pattern. So what is a Strangler Fig? This is always worth talking about. The Strangler Fig pattern was defined by Mark and Fowler, I think back in the 2000s. And the idea is that it's based on a Strangler Fig vine. So the vine drops a seed, and it's part of a tree, and it drops the seed, and it sends down a root, opposite to what this diagram's doing. And then it builds itself around it, slowly strangling out the nutrients from the tree until it remains and the old tree itself is removed. So like that, the Strangler Fig pattern takes away the responsibility from the old area of code, one slice at a time. And it's really great when you need to do an entire system replacement alongside the original with no downtime. This is a pattern that's been used by Uber, Netflix, and BBC when they were evolving to move to microservices. And it's great because it doesn't require downtimes. If you've got a legacy system that's poorly understood, you can intercept at the edge. And I've used it on systems before where you've had so much dependency drop that you just can't build the code on your machine anymore, and it's the only way that you can then take the responsibility away from something which may still be running in production, but you actually need to evolve. Massive advantages, yeah, the code that you're writing is effectively greenfield, but it's based on the legacy functionality. Oops, sorry. And replicating, you can leave behind the bad patterns, which is always good as well. There's no need to touch the legacy code bases before. You create a facade which makes a boundary, so you're keeping the old system frozen. The routing layer provides a natural place for feature flags. You can do A/B testing, you can do canary testing, you can do traffic rollback, and progress is visible. So you can start seeing the new traffic hitting the old systems. You can test it very well. The disadvantages with this system is that it requires effectively setting up and running two systems, and it's not a trivial cost in the boundary, especially for, like, you've got to maintain two infrastructures effectively. It does take some time to work out where the points of abstraction should be, where you can break these things apart. And it requires a commitment to completion. There's an awful lot of half-finished Strangler patterns out there where you've got some of the process has been started, some of the responsibility has been taken away, and then the impetus for continuing with it has been lost, which means that you're then left with a double maintenance headache, which can be cause a lot more stress and a lot more complexity for the teams. So a third option is the branch by extraction. So with branch by extraction, you are working from inside the code base rather than around it. You put an interface within the code, and you can then branch out to a new implementation. So something behind a feature flag, so that you then can route the traffic through to your new feature flag. It's great when you've got internal improvements and the code that need to remove from the area, so you can get rid of bad patterns or rot that may have crept into your code base. When you need to remove a deeply embedded component, this is one way to do it. It keeps the trunk releasable at all times. The abstraction layer makes the seam explicit, and you can easier to reason about what's old versus new. Both implementations are active at once, so you can compare behavior on production. So you just switch on your feature flag, check how it's working. That means you're testing as you're going, and that means that you're getting that constant feedback. And it actually naturally surfaces a lot of hidden dependencies and coupling that maybe other refactors might miss. The abstraction itself, the disadvantages is that it is another piece of code that you have to write and maintain and eventually delete. There's certain code bases which are littered with these abstractions that haven't been completely deleted, which again adds to the cognitive complexity of the code base. And if teams can lose motivation and leave these things half finished if you don't have a driver to complete it. It's also quite tedious to find these things in a large Brownfield code base, which is where AI can come in to help you. And the toggle and the routing logic does add cognitive overhead, like I've mentioned. It is much more like if you imagine a body, right, and you had to replace a kidney. If you go in there and you slice it and you remove the kidney and replace the kidney, it's much more like that sort of methodology. What a horrible metaphor. I'm sorry. But you all know what I mean, don't you? Right, so how do we use AI to apply these methodologies? It's tempting to think that you could just let AI loose on your code, but AI will confidently hallucinate about your code. When autonomous agents are deployed into established Brownfield code bases without strict guardrails, they don't really go rogue in a malicious way, but they typically cause havoc through over-optimization, generating dark code which passes all your tests and undermines the implicit architectural constraints, and then creating more hidden technical debt. I know this because as soon as I got given access to Cursor, first thing I did was like, oh, I wonder if I can refactor everything. I did not push anything to the code base because I saw the sort of mess it was making. And of course, it's 2026, and everybody knows that that would be a bad idea, surely. Nope. It's still happening. People are letting agents loose without bounded scopes, and it will do refactors that aren't tested, aren't maintainable, aren't grounded in what the code actually did. And as Don said in the previous talk, what you need is safety, safety, safety. So what do I do instead? So when I'm looking at a Brownfield code base, I don't start necessarily just with the code. I start with listening to the developers who are working on the code. they're the ones who are dealing with the problems that we're facing every day. And everybody who has worked on this code base will have a view with what is wrong with it, how it could be improved, and some areas where it maybe shouldn't be improved. And this kind of harks back to Adam Thornhill's, it's quite an old book now, called Your Code as a Crime Scene. And he talks about forensic investigations and looking at how you can do forensics across your code base. And this is just one piece of evidence. Your developers are excellent eyewitnesses. We did, I'm work fully remote, so we did it as a Miro exercise. Everybody had an opinion. We created a graph of value versus complexity, and we allowed everybody to bring to the table as we think these are areas where there could be opportunities for us to technically improve our code base. And then from there, we started focusing AI around those problems. And we started to, rather than do it as one big process, we focused down based on where the areas that we knew were problems. So for example, we knew that there was a significant amount of dead code within our backend code base. We focused in our cursor investigations to look at those. We looked for dead code paths, we looked for duplication, we looked for pattern inconsistencies, and we looked for complexity hotspots. We even did some OWASP style scanning, but we wouldn't say that's not to replace doing proper security scanning. It just gave us a sort of high level. These are areas of where your code base has got a bit smelly over time. And we started generating some dependency graphs. We started generating some maps of what the code is doing now, not what our documentation said the code was doing, because documentation has always been something that every developer loves to update regularly. So yeah, it does. It rots over time, and we know that. And the one thing that we found is that this process was made significantly faster. It still needs to be human reviewed because, yes, AI will confidently hallucinate about your code base, but it did mean that something very, very interesting happened. We had some objective data, and we found that when we had that data that people would look at it, it wasn't written by the cleverest person on the team. It was written by AI. So we had more people were willing to put in a view on this is right, this is wrong, I have observed something. Whereas previously you might have seen the principal engineer on the team would say, I think this is right, and everyone would just follow what they were saying. It was really good for that. It also helped to break the bike shedding bottleneck. So where everybody goes, this is what I think is wrong, this is what I think is wrong, and then there's just a fight about what is the best thing to work on first. We now had some objective data that we could say, we can actually see, we've got metrics that we can start looking at, we know where our coverage gaps are, and it gave us a way to prioritize the work that we needed to do, and it gave us a destination we wanted to work towards. So yeah, core principles for working in the Brownfield development. Don't trust the AI input blindly. Work in small scopes, try to keep it focused down. Yeah, remembering that you want people to read this afterwards. Version control everything. I mean, you don't want to be pushing anything up to your code bases without version control. Create a findings backlog and then prioritize your findings backlog. You can work through that as time goes on. Create human readable docs. This needs to be reviewed and understood by the team and the whole team. So make sure that you've got something that you can go back to and understand, and then put your guardrails in place. Tests, logs, static code analysis. We spent a lot of time before we did any of the actual implementation work, making sure that things like our Sonar Cube was up, running, working, and reporting as we expected to do, not what it, and made sure that we had confidence in the test suites that we had. And then once we did that, we decided to focus on one area at a time. So we used, you can either do that by specific feature requirement or specific technical requirement. And we made sure that we called out things that we found as we went as well. So we have rules that make sure that our skills don't repeat bad patterns that we have in the code base. It's very, very easy to go, oh, I see it's done it like this, I'll just do it like that again. We make sure that there's a clear definition of we want to see more like this pattern less like that pattern. And we keep those skills alongside our code now. Some examples. This is a pseudo greenfield approach, and it just gives you an idea of what we've actually done at NearForm and how powerful this can be. So yes, it feels like 6 months worth of scope was shipped in 8 weeks. It's an amazing statistic. We used spec-driven development on this, and the parts that were really useful on this is there was a huge amount of product requirements that had been produced but never actually implemented. So we used the AI to go through those and then create the PRDs to do this. We reverse engineered the product requirements from that documentation, and we reduced the time there from months to a week. We did a detailed code-based mapping, reverse engineered the documentation from the existing code base to the AI context. That reduced from 2 weeks to hours, and automated the story mapping. From the PRD creation, creating the Jura tickets, and this is something that it's always worth putting a little bit of time into, creating a skill that creates really good Jura tickets that anyone can pick up with because it just means that you can parallelize your work so much better. And the impact was the faster time to market. 6 months work in 8 weeks, 4 times faster than one of our competitors had estimated. So that's nice. But like I said, pseudo greenfield isn't right for every project. It was right for this one. Branch by abstraction. So this is a code base that I'm a little bit closer to, and it's 5,000 lines. Oh, sorry, 500,000 lines of code. So 500,000 lines of code. It's tightly coupled, distributed monolith. It's a large legacy brownfield architecture that we inherited from another supplier. Again, this is the kind of thing that happens all the time in the enterprise. The whole of the old development team may have disappeared. So you don't have that story of why it has been built up like this. There wasn't architectural decision records. There was a limited number of tests on it. And this sounds really simple, but all we wanted to do was update the version of AG Grid for the use of the latest features. And what we discovered when we tried to do this the first time was that the grids had been implemented individually without an inheritance pattern and no shared abstraction. So this meant that when we tried to do the very first time we upgraded AG Grid, it took us a significant amount of time. I don't actually have the metrics. I think it was about a month. And you think that's just upgrading from one version to another. And then because of that, you then have a problem of, well, how do we then move forward with this? How do we get better? You can't have that. That's a complete time sink. We can't keep having that time sink because all of these things like AG Grid, they're rapidly evolving now, especially with AI on their side too. So we don't want to be left behind. We don't want to keep in this space. We want to be able to use this. So what we did was we created a plan. And this is, I think, another difference between green and brownfield code bases. In a greenfield build, a discovery process is kind of expected. We expect to do a bit of discovery. We expect to do a bit of planning. We expect to have a think about what we're building before we actually build it. In a brownfield, it's often, let's all just dive in and just get this done mentality. And that can mean that the planning stage is forgotten. And something that, whilst we've been starting to move towards a more AI native way of working, the plan phase has extended, and we are putting more time into our planning because we want to do the proper archaeology on the code base, because we want to make sure that we're calling out the good path, and because we want to make sure we've got a structured roadmap. And from that, we then created something called a plan skill, which is all the technical and product considerations captured. And then the work was broken down by that great Jura component skill that we created. And then this is then handed off to our developer skill. The developer skill has, it's a multi-agent flow. So the orchestrator agent analyzes the requirements, and then it sends off various different agents to do a dedupe check, build the test scaffolding. Another agent does that. It looks at what's the implementation. It does static analysis and quality gates. And then it uses another agent to do a pre-review of its own work, before pushing it to the developer to do a human review of the work, before pushing it to a full human-in-the-loop sign-off to go through to the main development pipeline. And then once it's done that, it then goes back and updates the master plan. So if you think, we've got to do 80 of these, you want to do this right a few times, and then we've got a process now. So it starts out it was relatively slow to start out, so the first couple of these took a decent amount of time, so that as we work through the skill, getting it right, making sure it was robust. But we're seeing a flywheel effect with velocity improvements. We're starting to push these things through much, much quicker. And it's easier for the developers to run these almost in the background. They can just keep going. And another halo effect from this is that we are starting to build up a library of skills within our code base that we can then refer back to. This is what good looks like for a skill development. This is how the process that we're using for the skill. This is how we want to work. And that is then leveraging other areas of the code base that we can then start moving into, improving, and we're starting to get, like I say, flywheel effect of velocity improvement as we go. This is my practical takeaways slide, because I think that it's always good to be able to just remember what's good about doing this is start with a map, not a migration. Always start with thinking about what you need to do. Let your spec be the contract, making sure that you're thinking about what it is you want to build up front. That planning phase is so important, making sure that you're building the right thing. Think in slices and not rewrites. Do things in small chunks, because if you're chunking down the work, it's much, much easier for you to get through it, and you'll get to the point of, yep, that's done, let's move on to the next. And complexity is the opportunity. It's something where I think we can really, really lean into in the Brownfield. It does take a little bit longer, but once you're working in this way, you start seeing results very, very quickly. So there you go. That's how you can use AI to start paying down your technical debt.
Thank you very much, Katie Roberts. Any questions at all? One question. Where's lunch?
Yeah, I know. I'm standing between you and food. That's
especially as there's a kitchen just here, and I can smell it. So thank you all. Thank you again, Katie. Big round of applause.
Sorry, there's a question.
Oh, there's a question. One final question. You're not moving, any of you.
Thank you for a really great presentation. One thing that I want to know is, how do you divide the skills between different feature teams?
How do we divide the skills within the different feature teams?
Especially if you're like a monolith.
So we do it. We slice it at the epic level. So what you would normally have as an epic, we then slice that and give those to our feature teams. And then it might be our feature teams are very much smaller to work through those. So instead of being like 4 or 5 people, we can now do that with 1 or 2 people, so that they are working through with their agents, and that seems to be working quite well at the moment. There is always, you've got to be careful that you don't end up with skills diverging as well. So there has to be some collaboration, making sure that across the feature teams you're doing them in the same way, and that people are reviewing still what's going on. So you're not building silos of skills.
Thank you.
Thanks very much. Okay, class dismissed. See you back again after lunch.